hello everybody. We're going to be looking at lesson 23, rotations. So if you look at this image right here, here's what a rotation is. So I want you to imagine like a ceiling fan. Here's the center, and so this object is rotating around the center. So what that means is your distance from, say, the point to this base, your distance along this to the corner, or from here to the corner, or from corner to corner, those distances all stay the same. See, this length right here will still be the same as the length over here. The difference is you're taking the object, you're not just moving it up, down, left, right, you're literally rotating it. So in this case, since it's touching the center, this point will always be right here at 0, 0 throughout every rotation. All right, so that's what a rotation is going to look like. So the spinning type of transformation is called a rotation, and it is defined by the center of the rotation, which is mapped to itself, and the angle of rotation. The center of rotation may be part of the figure being rotated, as is the case shown above. So you see right here, it's rotating about a center, and the center is actually on this figure. If you think about, say, the moon rotates around the Earth, but the Earth isn't part of the moon. So the moon is rotating around something that's not part of it. So your center of rotation can be a point outside the figure, which is the case for the moon rotating around the Earth, or the Earth rotating around the sun. Functions can be described. Functions that describe rotations include, you could put x, y, and what happens is if you switch x and y, but so say if it's like 1, 2, you switch it, make it 2, 1, but make this negative, so make it 2, -1. That is how you can do a rotation, which will be a clockwise rotation of 90 degrees. So that would be example from here to here. If you go from x, y, and you just keep them in their place, but make them -x, -y, that's a rotation of 180 degrees, which would be going from here to here, so half of a circle. And then if you change the place of x and y, but make the new x right here, which was the old y, make this negative, it's going to be a clockwise rotation of 270 or a 90-degree counterclockwise rotation. So this is why I need to have a video running. I need to make sure you understand some stuff like this. So when you're doing a rotation, it might confuse you to hear 90 degrees. You might have thought that's only an angle. So remember, if you're doing a circle, anybody who is ever into skateboarding, snowboarding, anything like that, you actually probably be familiar with these just from how many, with a spin, 360, and then, like a 900 was a famous rotation Tony Hawk did years ago, or the 1080. So the idea is this: if you're doing a circle, a full circle is 360 degrees. If what you do, you rotate from here to here, that's a 90-degree rotation. And if you rotate to here, that's 180-degree rotation. And if you rotate here, that's 270-degree rotation. Or that's why it says, so this is all going this way, which is clockwise. Okay, or you could rotate this way, which is counterclockwise. And in this case, going from here over to here, you could either call it a 270 clockwise rotation, or it's 90 degrees counterclockwise, because it's just a quarter of a circle. So we're going to be using that as we go through these. So, and then to clarify what was in that little opening paragraph. So if we look, what the opening paragraph is telling us is that if you do a rotation from, let's say, so if we're like that, if we rotate to right here, look at what it says. That would be a clockwise rotation of 90 degrees. And for that, notice what it says. A clockwise rotation of 90 is taking x and y and making it y -x. So if our original figure is x, y, then to make it clockwise, it then becomes y, -x. Okay, which seems kind of random. You might look at that and think that's kind of hard to remember. But think about it. It does make sense, because look right here. In this case, let's say if x was up here and it's 3. So if x is right here and x is at 0, right? If this is the y-axis, the x-axis. Well, now look, what's 0 right now? The x value is 0. So basically, if this was 0, Well, now instead of x being 0, this is kind of weird because of the negative, but the idea would be that we have the x here. Now put that 0 here where y belongs. So boom, we'd have a 0 there. Notice that x was 0, now y is 0. So it's basically saying you switch them. And then if y was up here at 3, well, now you take that 3 and you put it in the front. So if we just look, we went from 0, 3 to 3, 0, which makes sense. We're up here at 0, 3, now we're at 3, 0. So that little formula works out. So then if you go down here, a 180 degree rotation, what you did, whatever x was up here, it just becomes a negative x. And then the y up here becomes negative. And then to go right here, which we're calling either a clockwise 270 or a counterclockwise of 90, to end up right here, once again, you just switch the numbers that are at y and x, but you make the y negative. Okay, so that's what it's going to look like when we do these. I'll keep this up here and I'll just move where I'm looking out on the board as I do problems, and I'll go back to that when needed. So let's look at the first question. So let's do this. You go ahead and pause, try to do 1 and 2, and then press play. Okay, hopefully you've done 1 and 2. This is pretty simple right now because you're just thinking, if I do the rotation, that gives me a y negative x. So what you're going to do, you'll take whatever y was, put that in front for the new x. So instead of 310, it becomes 10, 3, but then make this back number negative. So you just take 310, which was x comma y, and switch them. So you have 10 comma negative 3, which we have right here. And then right here, 310 goes through, becomes negative x, negative y. So just leave them where they are, make them both negative. Negative 3, negative 10. All right, now let's use this figure, and they want us to think about, so I want you to try this yourself, and then you can listen to me go through it. So I want you to try to do 3, 4, and 5. Press pause, do 3, 4, and 5, and then press play. Okay, so which direction would the arrow be facing after a clockwise rotation of 90 degrees? So clockwise rotation of 90 degrees, remember clockwise goes this direction, and you're going to take this thing and just imagine if it's the blade of a helicopter or it's the arm of a fan, and you're rotating around this center. So you rotate clockwise rotation of 90 degrees, boom, it'll be right here facing to the right. So clockwise rotation of 90 degrees will make it face right. A rotation of 180 degrees makes it flip completely upside down, so it faces down. And then a rotation of 90 degrees clockwise, you're rotating to the left, so it'll face to the left. All right, now what we're going to do, we have image 1, image 2, and image 3. Which rotation would turn the black pre-image into image 1? So which rotation gives us a counterclockwise rotation of 90 or a clockwise rotation of 270? So to figure this one out, you're going to use the stuff I was going over earlier. So I want you to try to do 6, 7, and 8. Okay, go ahead and try to do 6, 7, and 8. So press pause, try 6, 7, and 8, and then press play. Okay, so number 6. This is where we're going to look at what I drew up here. So in order to rotate from here to there, what are you doing? Notice what you're doing. Whatever your y was up here, that's the value of your x over here, but it has to be negative. And then whatever your x was, that's what your new y is. So what we do is we swap those and we make the thing in front, the old y, which is now the new x negative. So in order to make arrow 1 happen, you need to do negative y comma x. In order to make number 2 happen, right here, notice what we're doing. We're taking whatever our x was, and that's our new y, and whatever our y was becomes our new x. So let me go to the image. So look, in order to get right here, you take y and x, you flip them, but look at what becomes negative. The x becomes negative in this case. So in order to do this rotation where it goes to the right, we need to be doing y negative x. And then lastly, how do we get to image 3? So we're at x comma y, and we're just going to take it, and everything's going to stay in the same place, but we're going to make them negatives. So negative x comma negative y. Okay. Now I want you to describe, say, what's rotating, how much does it rotate, and how much does it, what's the center of rotation. So in your description here, so I want you to pause, you're going to look at this. How does A turn into B? You're going to say, what's the center it rotates around, and what's the degree of the rotation. So go ahead and pause, try this, and then we'll go over it. Okay, so here's A, and what's happening with this is it turns into B, and with B, it has a corner right there. Okay, so, and then B goes up like this, and it goes over 1, 2, 3, 4. So you gotta imagine, how do you rotate this thing into that? You don't rotate around 0, 0. That's not your center of rotation. If that was the case, then when this rotates downwards, it would still be attached right here, and it would actually look like this. You see that? If this was your center and it's spinning around that, it would look like that. That's not what we have. What's happening is, look at it like this. This right here is your center. So it's like this corner is pinned to that, and it's spinning around that. So what you would say is, and how much did it spin? Did it spin 90? Did it spin 180 or 270 clockwise? So you'll say it's a 90 degree. This is why I had you type it. 90 degree clockwise rotation. And what's the center? A 90 degrees clockwise rotation, but you can't just say that, because how do we know? What if it's spinning around this center, or around a center right here, or around a center right here in the middle of it? You need to say where the center of rotation is. What's it circling around? So you would say 90 degree clockwise rotation around, and what's this point right here? 1, 0. So that's what you'll need to type in there. A 90 degree clockwise rotation around the point 1, 0. That's what's happening there. I hope you can see that, how this is the center. That's the hard part with this kind of thing, is identifying the center. All right. So now what we're going to do, we're going to get used to something. This is going to come up a lot in the next lesson. In the next lesson, we're going to put all of these types of transformations together, and we're going to use stuff like what you see right here. So in order to describe a rotation, we're going to use the notation picture below. This right here, where you have R, and then you're going to have a little O, comma, an M, but here's how it's going to work. This capital R tells us we're doing a rotation. What you'll see is we'll start using like lowercase r for reflections, and we'll have other notations in the next lesson. But an uppercase R says I'm rotating, tells us what we're doing. And then this little O that's right here, that's the point. So this isn't always going to be an O. Notice like in these. So we'll have, sometimes we could have an O, sometimes we could have a C, sometimes we could have an A. That depends if we're rotating around point O, point C, point B, point A. So what you're going to do is you tell me what the center is. So in this case, since you rotated around the point 1, 0, we would say R 1, 0. That's what would be right here. And then you say M degrees. So you're going to say 90, 180, 270. But here's going to be the rule. This is what's kind of weird, is that positive degrees actually represents counterclockwise, and negative will represent clockwise. So what that means is that we're going to say rotating this way will be positive. Okay? Rotating this way will be negative. That way we don't have to write clockwise, counterclockwise anymore. We're just going to say this is the normal way to spin, so this will be the negative way to spin. And you're going to see that a lot. Some of you might be bothered by that. You might be thinking, man, clockwise should be normal. Clockwise should be positive. The reason that we're getting used to thinking about that is because what's going to start happening a lot, especially in trig, is you'll start drawing angles where you always assume that this is where they start. And so what will happen is like this would be a 30-degree angle. And then this would be a 90-degree angle. And then this would be 180. So if you go this way, this would be negative 30. So what's going to happen when you hit trig, this direction is the positive direction. This is the negative direction. That's why you're getting used to that now. Okay, so to the example we did a second ago, where you have this right here, and then you have this right here, and we decided this point is 1, 0. The way you would use this notation I'm showing you, you would say R because it's a rotation. You would say 1, 0 is the center, and then you would say 90 degrees is the rotation, but you'd say negative because it's clockwise. So you'd say R10 negative 90 to say we have this object, 10 is the center of rotation, and it rotates negative 90 or clockwise 90 degrees. This is really important. We will practice this a lot more in the next lesson, but you need to start getting used to this now. So what I want you to do, I want you to use this. Remember, R for rotation. Whatever is right here is the point that you're circling around, and then this is the degrees you're rotating. Remember, on a circle, 90 is a quarter of a turn, 180 is a half a turn, 270 is 3/4, 360 is the full circle, and traveling in this direction is going to be negative. A circle going in this direction is negative. Circle going in this direction is positive, okay? Use that, and I want you to try to do these 3 questions, okay? So read what this notation is, make sense of what it's trying to tell you to do, and figure out which 1, 2, or 3 represents that. So press pause, try these last 3 questions, and then you can press play. Okay, so let's finish this thing up. So R0 or O, negative 90. So here's what we're going to do. Black is the pre-image. Which one of these is taking this and rotating it around point O? So point O is your center of rotation. You're circling around that. Which one does that negative 90? So a clockwise rotation of 90 degrees. Well, let's think. If this is the center, let me give you kind of like an example. Look at this pen. If I'm circling around, say, my finger right here, it's going to rotate like that around my finger. Let me get right in the center. So if I'm rotating around my finger, it's going to look like that as I rotate around my finger. But look, if I'm rotating around my finger right now, what's it going to do? It's just going to stay in one place and just spin because the center is in the middle of it. So look at right here. If this thing's right here, it's circling around this. It's going to keep this will be the center of it, and to rotate negative 90 is a clockwise of 90, which you put it right here. So for this one, you'll use image 2. Okay, how do we get this one right here? Rotate around C 90 degrees. Remember, positive 90 circles like this, counterclockwise. So let's look at it. Where's C? Okay, here's C. So which one is starting up here and rotating in this direction 90 degrees around C? That would be 3 right here. Look, because C is on this corner, as you rotate, this corner will always stay there. So see, this corner is what was right there. This corner is what was up here. This corner on top is what was up here on top. So this started up here and it rotated down there. And then let's do last but not least. We have a rotation. We rotate around point A and we do it 90 degrees. Positive 90. So we're circling like this, counterclockwise. Here's A. You keep your point on A and you rotate like this, 90 degrees. So we get 1. So that's our final answer. So make sure you understand this. Make sure you can use this because we're going to use this. We're going to do reflections. We're going to do translations. We're going to do them all in one lesson using notation like this to describe all of them. So we're really going to put everything all together. So if you have any questions, email me. Other than that, have a great day.